dear student. I'm Saktwala from Educare TZ. I will be with you in physics for Form 3. And today we are going to proceed with our revision question for the topic of the measurement of SM energy. Today we will proceed with the question number 16. And let us read together our question here. And after there, we will summarize the given data so as to identify the unknown value. Now, our question is said that a metal sphere of unknown composition, that we have the metal sphere and that metal sphere has unknown composition but involve a mass of 0.4 kilogram. But the sphere is heated in a furnace to a temperature of 150 centigrade. And then it dropped into insulated cup holding 0.35 kilogram of water at a temperature of 20 centigrade. Upon reaching the same equilibrium, the temperature of the system is measured to be 32.4 centigrade. Now, my dear student, from our question here, first of all, you have to read carefully your question, and after there, make sure you have understood your question so that you can find the unknown value. Now, let us repeat again our question so that we can gain more knowledge on how we can answer this question. Here, we have two things. We have the metal sphere and also we have the insulated cup. It means that insulated cup is the cup where the metal sphere is dropped. And also we have the water here, and the water involves the specific heat capacity. Now, on your question here, the question is based on the metal sphere and also based on the water. Now, our metal sphere, we have the mass of a metal sphere here, which is 0.4 kilogram. And also we have it is temperature. And therefore, we have finally the water, the mass of water, the insulated cup which holding the water. It involves the mass of 0.35 kilogram. And also involve it is initial temperature. Now, my dear student, after reading your question, let us go together so that we can summarize our given values. Now, first of all, our question needs us to calculate the specific heat capacity of the metal. That is, what is the specific heat capacity of the metal, but the specific heat capacity of water we have given there. And the Roman B, we are supposed to use the value of specific heat capacity in table 7.1 to identify the metal. Now, first of all, let us focus for Roman A. And for Roman A, we are supposed to find the specific heat capacity of metal. Let us go and summarize our data. Now, from our question here, we have the value, the data given. We have the value here. We have given the value. Now, we have the mass of a metal sphere, as we have seen there. That the mass of a metal sphere is labeled or is represented by M1, which is 0.4 kilogram. And also, we have the initial temperature of the metal sphere. That the metal sphere involves it is temperature, it is initial temperature. And also, we have the mass of water, and the mass of water is represented by M2, which is 0.35 kilogram. Also, we have the initial temperature of the system. No, it means the final temperature of the system. This is an error. This it represents the final temperature of the system. That is why it is indicated by TF, means the final temperature of the system. Now, also we have the specific heat capacity of water. On our question, you have been given the specific heat capacity of water, which is always constant, ambayo inakuwa ni 4200 joule per kilogram centigrade. And also we have the final temperature of water. Now, on our question, we have given it the final temperature of water, which is this one, labeled by T2. Now, after that, my dear student, our question needs us to find the specific heat capacity of the mesosphere, and that is why it's labeled by Cm. It means the specific heat capacity of the mesosphere. Then after there, we can use the principle of heat exchange. So in order to solve this question, we have to use the principle of heat exchange. It means that the heat gained is equal to the heat lost by a compound. Now, as we see here, we have heat lost by the mesosphere is equal to heat gained by water. We can make equalization. It means that heat lost by that mesosphere equals to the heat gained by water. And here after there, we can summarize the formula of finding the heat lost by the mesosphere, and also the formula of getting the heat gained by the water. We can substitute it. Now we can get M1. It means the mass of the mesosphere is times the specific heat capacity of the mesosphere. You times by the temperature, initial temperature of the mesosphere minus the final temperature, and also equals to the mass of water times the specific heat capacity of water times the bracket temperature final minus the temperature initial. Here, my dear student, as we see here, that always in order to get the heat loss, it means the initial temperature must be greater than the final temperature. And if we want to get the heat gained, it implies that the heat gained, it means that the final temperature must be greater than the initial temperature. And now you can see here, this is the initial temperature. For heat to be lost, it means the initial temperature must be greater than the final temperature. And also for heat to be gained, the final temperature must be greater than the initial temperature. And that is why we have writing like this one. And after there, my dear student, we can substitute the value that we have given from our question. If we substitute it, we can put the mass. We have the mass. If we substitute the value that we have been given from our question here, now the remaining unknown value is the specific heat capacity of the mesosphere. And that after there, you can simplify. And after simplifying it, you can make the specific heat capacity of metal as a subject. Now, after substituting and multiplying it, you can get the specific heat capacity of the mesosphere equals to this value over this value. It means the specific heat capacity of water will be of mesosphere will be equals to 43.6 Joule per kilogram centigrade. Now, and this will be the final. This will be the conclusion of the question Roman A, because our Roman A need us to find the specific heat capacity of the mesosphere, and we have get the specific heat capacity of the mesosphere. And after there, you can conclude by saying that the specific heat capacity of the mesosphere will be equals to 403.6 Joule per kilogram centigrade degree. And after there, my dear student, our question categorized into two parts for Roman A and Roman B. And now let us go and see for the answer of Roman B. And our Roman B need us to identify the metal using the value of specific heat capacity in table 7.1. And from our question here, we don't have the table, but the table is obtained from our book of TAI, the Tanzania Institute of Education. And if you will go and look for that, you will see that table which is needed from our question here. And after there, in order to identify, to use the values in order to identify the specific heat capacity in table 7.4.1. First of all, compare the calculated specific heat capacity with the value in table 7.1. That in order to identify the specific heat capacity that is indicated on the table 7.1, first of all, we have to compare that the value or the specific heat capacity of the element or of the metals listed on table 7.1 must be similar or approximately with this specific heat capacity that we have been obtained on Roman A. Now, let us proceed. The metal with a specific capacity closely to the calculated value is the copper, which has here. Kwamba ukiangalia ile specific heat capacity tuliyoipata na ukajaribu kulinganisha na iliyopo kwenye table, utaweza kupata kwamba copper ndo specific heat capacity ambayo ilikuwa inahitajika kwenye swali, kwa sababu thamani yake imeweza kufanana na ile value ambayo tumeweza kuitafuta kwenye Roman A. Now, my dear student, after seeing that, you have to conclude your answer here. That therefore, because the specific heat capacity, the calculated specific heat capacity is similar or is approximated with the copper, which is indicated on a table 7.1, and that will be the copper. This means that, therefore, the specific heat capacity of the metal is approximately to this one, and here. The metal is likely the copper, and on our question we have been asked to mention that metals, and now you can conclude by mentioning that metals as I have mentioned here, that that metal will be a copper because its value is similar with the calculated value from the question Roman A. And after there, my dear student, let us go and see the question number 17 here. And our question number 17 said that, explain why a piece of ice at 0 centigrade is more effective in cooling a drink at room temperature than an equal mass of water. As I told you, my dear student, that for the question of physics, first of all, you have to read your question and ensure that you have understanding the needs of your question. That you can't answer your question without understanding the needs of your question. And if you read on the first time and you are not understanding, you have to repeat again so that you can understand well your question. Now, let us repeat again our question here. Explain why a piece of ice at temperature 0 centigrade is more effective in cooling a drink at a room temperature than an equal mass of water at 0 centigrade. Now, my dear student, before you jump and see the answer of this question, you have to ask yourself that, kwa nini a piece of ice, kwa nini kipande cha barafu chenye centigrade ya sifuri, chenye temperature ya 0 centigrade kinakuwa na nguvu kubwa sana ya kuweza kupoza a drinking at room temperature, kwamba yale ya kuweza kupoza kitu cha baridi au kuweza kupoza kama ni maji, kwamba kwa nini sana sana kipande cha barafu chenye temperature ya 0 centigrade kinatumika kuweza kupoza kama ni maji yalikuwa ya moto, wakikiweka humo kinakuwa na nguvu zaidi ya kuweza kupoza yale maji, ya kuweza kuyaweka yale maji yawe ya baridi. Kwamba ni kwa sababu gani? At room temperature, as has been told here, than equal mass of water at there. Now, let us go and see our answer, my dear student. Our answer is this. The piece of ice is at a 0 centigrade is more effective for a cooling drinking due to the latent heat of fusion. the reason is the latent heat of fusion. Why I say that the reason is the latent heat of fusion? This is because energy absorption and cooling effect, when ice melt, it absorb a significant amount of energy to its surrounding. Kwamba kwa nini tumeichagua ile latent heat of fusion kuwa ni sababu ya kile kipande cha barafu kuwa na nguvu zaidi kuweza kupoza kama ni maji ya moto yanakuwa ni ya baridi. Kwamba ni kwa nini, kwa sababu gani tumeweza kuchagua? Kwamba kwa sababu ile latent heat of fusion kama tulivyosoma kwenye definition kwamba yenyewe inakuwa inatumika sana sana kuweza kuconvert kwamba kitu kilikuwa ni kigumu alafu kinakuwa ni liquid. Na pia ukiachana na hivyo au kinyume chake, inaweza ikawa inatumika kuconvert the liquid into a gases, au inakuwa ina take place at a freezing point or the melting point. Ndio maana tumeweza kuchagua kuwa latent heat of fusion inakuwa ni reason for why the piece of ice at 0 centigrade be more effectively for the cooling of a drink. Let us proceed reading our answer here. This energy is called the latent heat of fusion. It is the energy required to break the bonds. Kwa sababu ile latent heat of fusion inakuwa inatumika sana sana kuweza kubreak, it means kwamba kuvunja ile bonds between the ice molecule turning into the liquid. Ni kama nilivyosema kwamba kazi ya latent heat of fusion ni kuweza kubreak, kuvunja kwamba kama kitu kilikuwa ni kigumu, hii unataka ukiweke kuwa ni kimiminika, tunacho apply sana sana, tuna apply the latent heat of fusion in order to convert it from the solid into the liquid. And after there, my dear student, this will be the reason for our question. Now let us jump for another question here. As you see here, our 18th question, that our question said that a refrigerator can convert 600 grams of water at a temperature of 50 centigrade to ice at 0 centigrade in 3.5 hours. Find the average rate of heat absorbed from the water in what? Specific heat capacity of the water is here, and also we have the specific latent heat of fusion, which is this one, and also we have the specific heat capacity of ice, which is 100 joule per kilogram centigrade. As you see here our question. Now let us turn back and repeat again reading our question so that we can identify the needs of our question and which formula we can use so as to find the unknown value or the unknown parts. Now my dear student, here a refrigerator can convert, kwamba tunajua kwa kwamba the ability of a refrigerator is to convert something in one part of an object into another part. Now here a refrigerator can convert 600 gramu of water, kwamba ile refrigerator ilikuwa inatumika sana sana kuweza kubadilisha masi ya 600 gramu of water at temperature hii hapa kuipeleka kwenye ice, lakini at temperature hii hapa kwa ndani ya masaa 3.5 hours. Akakwambia find the average rate of heat absorbed from the water in what? Our question need us to find the average rate of heat absorbed, and we know that when we talk about the average rate of the heat, it means we are supposed to find the power, because the power is always obtained by taking the energy per unit time. That is why our question needs us to find the energy, the rate of energy absorbed, the rate of energy absorbed. Now, after reading your question, let us go and summarize so that you can identify which value we can identify, how we can find the heat, the average rate of heat absorbed. Now, my dear student, from our question, we have the mass of water, that we have been given the mass of water, which is 600 grams. Now, according from our formula, we are supposed to put our mass into a kilogram. Now we can convert this gram into a kilogram by taking 1 kilogram represent 1000 gram, and which kilogram will it be for 600 gram? You can get is 0.6 kilogram. And also, we have the initial temperature of water, which is 50 centigrade. And also, we have the final temperature, which is 0 centigrade here. And we have the time taken, which is 3.5 hours. But our time, we have given our time in terms of hour. We can convert it into a second. How can you convert your time from hour into a second? First of all, you have to take your time from hour into a minute, and after there you will take a minute into a second, and after converting it you will get this one. It means that 3.5 hours will be equals to 12300 seconds. And after there, my dear student, you can summarize again the specific heat capacity of water, which is 4200 joule per kilogram centigrade. And also, we have from our question the constant value. Also, we have the specific latent heat of fusion, which is equal to this one. And also, we have the specific heat capacity of ice, which is this one. You can ask yourself, why from our question you have been given the latent heat of fusion? You can ask yourself that kwa nini kwenye swali letu tumeweza kupewa ile specific heat capacity of fusion, the specific heat capacity of fusion, kwamba tumepewa specific heat capacity of fusion kwa sababu ile ndo itaweza kutumika kubadilisha kama ni barafu inakuwa ni maji, au kama ni maji tunataka tuyaweke yawe ni barafu. Hiti itakayohitajika sana sana kuweza kuconvert ni ile specific latent heat of fusion. And after there, my dear student, now required to find the average rate of heat absorbed. How can you calculate the latent heat, the average rate of heat absorbed? First of all, heat absorbed to cool a water, that we are supposed to find the heat that can be used to cool the water. It means to put the water from in forms of water into an ice. Now, the quantity required to convert or to cool the water, it can be obtained by taking the mass of water times the specific heat capacity of water times the temperature initial minus the temperature final. And after there, you will substitute the given values, and after substituting it, you will get the quantity of heat which is equal to this one. And after there, you will write that the heat absorbed to convert water to ice at hii hapa utamwambia ni hii ambayo tumepewa 1,126,000 joule. And after there, my dear student, after converting, after finding the water, the quantity of heat that is required to be absorbed, we can go and find the quantity of heat that is used to convert water into an ice, kwamba ni kiasi gani cha heat ambacho kitaweza kuhitajika ili kuweza kubadilisha yale maji kuyapeleka kuwa ni barafu. This can be obtained by taking the mass of an object times the latent heat of fusion, and this always we can substitute it, and after substituting it you can get the quantity of heat, the heat that is used to change water into an ice. And after getting it, you have to record that the total heat absorbed. So in order to get the total absorbed during the experiment or during the process of converting, can be obtained by taking the quantity of heat 1, you add by the quantity of heat 2. It means the quantity of heat obtained from the latent heat of fusion and the quantity of heat obtained when the water is cooled. And after there, you will substitute, and after substituting it, you will get the quantity of heat which is this one, ambayo inakuwa ni 326,400 joule. And after there, after getting it, you will say, our question needs us to find the power. But there we have get the total heat. Now we can use the total heat so as to get the rate of heat to be absorbed. And the rate of heat to be absorbed is obtained by taking the quantity of heat, total heat absorbed over the time taken. And all of this we have been obtained above. Now you can substitute, and after substituting it, you can get the power, the rate of heat to be absorbed during the processing. And after there, you will conclude by saying that the average rate of heat absorbed from the water is approximately to 25.9 watt. And this will be the end of our question. And now, my dear student, this is the end of our session. Thank you for following us. I would like to invite you again for the next session.